This is our sun. It's a titanic, raging sphere of nuclear fire, an immense cosmic fusion reactor of unimaginable power that our very existence depends on. You would have to line up 109 Earths side by side just to be able to match its 865,000-mile diameter. If the sun were hollow, you could fit over 1.3 million Earths inside it, and you would still have room to spare. It would take a 747 jetliner flying non-stop 6 months to fly around it. It utterly dominates our entire solar system and accounts for 99.86% of the total mass within it. That means that everything else that circles our sun, every planet, asteroid, and meteor, accounts for just 0.14%. Its gravity is the invisible chain holding the planets in place, a force that is 28 times stronger compared to what you feel on Earth. If you weighed 200 pounds and could stand on the sun's surface, you would weigh nearly 3 tons. You would be crushed instantly under the weight of your own body. But gravity isn't its only destructive weapon. The sun burns at a staggering temperature of 15 million degrees Celsius in its core. Deep inside this behemoth, hydrogen atoms are crushed together with such immense force that they fuse into helium. It's an unrelenting nuclear fusion furnace, converting 600 million tons of hydrogen into helium every second, unleashing 3.8 times 10 to the power of 26 watts, an unthinkable amount of energy. To put that into perspective, in just 1 second, the sun releases more energy than humanity has produced in its entire history. A single second of its energy output would be enough to power our entire civilization for over 500,000 years. Every hydrogen atom fusing in the sun's core was born in the aftermath of the Big Bang, 13.8 billion years ago. It contains 10 to the power of 57 atoms, an incomprehensible number of molecules amassed in one place. That's a 10 followed by 57 zeros, also known as 1 octodecillion. They are locked in a violent ballet of collisions at speeds exceeding 500 kilometers per second. A single photon created in the sun's core can take up to 1 million years just to reach the surface. When it finally bursts free into space, it races 98 million miles to Earth in just 8 minutes and 20 seconds. A speed that is also known as the speed of light. That means the sunlight hitting your face began its journey before humans even existed. The surface of the sun, called the Photosphere, is a cool 5,500 degrees Celsius. Even at this diminished temperature, it wouldn't just melt, it would vaporize anything and everything known to humanity almost instantly. Without Earth's atmosphere to filter and scatter its rays, the unfiltered sunlight would scorch your skin in seconds, boil the fluid in your eyes, and fry the DNA in your cells beyond repair. Move closer into the inner solar system, and the intensity of radiation increases at the inverse square law. That means, if you move 3 times closer to the sun, the radiation hitting you increases by 9-fold. If you get to the orbit of Mercury, you would vaporize before you could even think of screaming for help. But the sun isn't a docile, peaceful star. It unleashes massive bursts of energy through solar flares and coronal mass ejections that can exceed the total output of all the world's nuclear weapons by hundreds of thousands of times. A single solar flare can release the equivalent of millions of 100 megaton hydrogen bombs in a matter of minutes. Even an average solar flare is wider than 10 Earths placed side by side, with the largest flares towering high enough to swallow our planet 100 times over. These eruptions also emit X-rays and ultraviolet radiation, powerful enough to strip away our atmosphere if the Earth were too close. When a coronal mass ejection erupts, an immense bubble of charged particles and magnetic fields erupts from the surface of the Sun. An unimaginable amount of mass, weighing up to 10 billion tons, races through space at up to 2,000 miles per second. If one of these hit Earth directly, a global calamity would ensue. It would fry satellites, knock out entire power grids on a continental scale, and bathe our planet in a storm of radiation strong enough to disrupt global communications. It would even damage our ozone layer permanently. The most powerful solar storm ever recorded was the 1859 Carrington event. It set telegraph wires on fire and made the Aurora Borealis visible, as far south as the Caribbean. If an event of that magnitude occurred today, modern civilization would face a global catastrophe. Our civilization is entirely dependent on electronics, satellites, and long-range power grids. These are the kind of systems that a huge solar storm would annihilate in a matter of minutes. But luckily, our Sun is stable, at least for now. Compared to the violent instability of the majority of stars in our galaxy, it burns with a steady rhythm, having remained in its main sequence phase for about 4.6 billion years. The energy that reaches Earth is only a tiny fraction of what it emits, yet it's enough to drive every weather system, fuel every plant through photosynthesis, and warm our oceans. Without it, the temperature of Earth would eventually plunge to near absolute zero, ending all present and future life. The Sun releases a continuous stream of charged particles, also known as the solar wind, which flows outward and shapes the boundaries of our solar system. This creates the Heliosphere, an immense 11.4 billion-mile bubble pushing back cosmic rays and forming a shield that protects the planets from galactic radiation. When this solar wind interacts with Earth's magnetic field, it paints the sky with auroras that we call the Northern Lights. A beautiful side effect of an otherwise lethal force. Our Sun may be an ordinary G-type main sequence star, but it remains one of the most stable and reliable power sources in the universe. At the Sun's surface, its magnetic field is twice as strong as Earth's, but in active regions such as sunspots, it can surge to thousands of times in strength. The real danger isn't the field's raw power, it's the sheer scale and violence with which it twists and snaps, hurling billions of tons of plasma across hundreds of millions of miles. Even if you stood on the surface of Mercury 36 million miles from the Sun, its magnetic forces would bombard you with deadly radiation, unleashing particle storms so intense they would tear apart your DNA and every cell in your body in less than a second. And yet our Sun is the one thing keeping us alive, and ironically the one thing that could erase us in an instant. Its fusion engine will rage for 10 billion years, and when it reaches its end, it will swell into a red giant consuming Mercury, Venus, and perhaps even Earth. It will swell to over 250 times its current size. Its outer layers will scorch the inner planets before it finally sheds its mass, creating a glowing planetary nebula. What will remain will be a white dwarf, a stellar corpse about the size of Earth, but still containing half the Sun's mass, with gravity 300,000 times stronger than that of Earth's. Even in death, it will remain a reminder of its power. The atoms forged in its core, including the carbon in our bodies and the oxygen in our lungs, will drift into space, eventually becoming part of new stars, planets, and perhaps even life somewhere else. Everything we are and everything we have ever known exists because of the Sun's relentless nuclear fire. It is our provider of life. But our Sun is also our eventual executioner.